I'm Mike Flower. I'm part of Dremio's solution architecture team. I'll talk a little bit about Dremio during this discussion. But yeah, we're going to talk as well today more about some of the buzzwords that people have been banding around. Things like phrases like a data lakehouse and so on. I'm going to also look at using some open source tools. I'm looking at Apache Spark, Iceberg, and Dremio. If you've got any questions, please shout up during, or we've got a booth here as well, so I'm more than happy to take questions later back on the booth too. This is what we're going to be talking about in the next 50 minutes. What is a lakehouse? So buzzword-tastic time. Some components which comprise a data lakehouse. Also an open lakehouse as well. Then we're going to go into some other phraseology such as table format, not just file types, but why do we need table formats as well. And then how all those components integrate. I'm also going to try and do a live demo, which is seat of the pants, considering we're here in a room where I haven't had a chance to run it through completely, so bear with me on that. And then we'll look at what's next, as in future, where we think the data lakehouse will be going next, and some of the other challenges that we foresee and how we think we'll address those as well. So what is an open data lakehouse? We've come across these phrases quite a lot. I'll talk you through a timeline in a moment as well. But pretty simply, we've got data in a data lake. You want the capabilities of a data warehouse. So that's a data lakehouse, right? You want to run data queries, manipulate the data using SQL, but on data that's in an open format as well. So we want to use open standards. You want to use things like SQL and Spark to expose and create those data sets, but also to be able to manipulate those data sets as well on data sets that are not in a proprietary format. So maybe stored in things like blob stores, ADLS, S3, Google Cloud, or even HDFS as well. And this other element called an open table format as also the ability to manipulate the data. So the idea being comprising of is that really you don't have any vendor lock-in on any of this. Right, so you can use whichever tools you want to do whichever pieces of the architecture you want as well. So you can access those data sets using tool A or tool B, can be used by multiple engines to manipulate and access that data as well. So if you take out one of the tools, everything else is still there. You've not been locked into any vendor at any stage. So that's what we mean by an open data lakehouse as well. To give you an idea, the timelines on here, right, are very vague. I mean, we're not saying that the data warehouse died in 2010. We're just saying really when these were predominant. Okay, so we started here by talking about, right from the 80s, talking about really relational database management systems, Oracle, Teradata, SQL Server, I guess as well, DB2. And those were storing data primarily on-premise, maybe even using proprietary storage components as well as proprietary data formats as well. So once you'd loaded that data into Oracle, you couldn't access it via SQL Server very easily as well, unless you went via Oracle to get to it. So Oracle couldn't be taken out. And those are predominant still. So I'm not saying they say this even in this day. They're still being used, right? So, but then what started to happen though was almost in parallel started to introduce these concepts of data lakes. Okay, so a data lake, essentially, pretty simply, is cheap storage. You've got the ability to have data which is spread over maybe multiple storage nodes, but actually presented to you as a single folder, single physical object. And so we started to look at things like Hadoop Distributed File System, so HDFS, but also S3, GCP, ADLS as well, so depending on which of your cloud vendors. And even then on-premise stuff, I mean, people did use HDFS on-premise, but also you could use S3 compatible storage layers as well. I know Pure Storage are here. They've got one. So you could be using other elements as well to get your data. And typically that was then stored for things like archiving. It's a big dump of data where we didn't know what else to put it. We didn't want to store it in our data warehouse because they charged us for the storage on that. So we wanted to put that data somewhere. That then caused some other challenges to how you then start exposing that data to run queries then once you've realized I've put it in this big garage or this big loft. How do I get the data out again? So then people then started to look at some of the other elements of cloud infrastructure, maybe using the operational costs, lowering that because you didn't have to run a data center anymore. So we started to look at almost like enterprise data warehouses, but running in the cloud. So taking advantage maybe of some of that cheap storage as well, because storage is a lot cheaper in the cloud. And then we saw the advent of things like Redshift, Snowflake coming along, which were running predominantly those same enterprise data warehouse workloads, but on cloud infrastructure instead. I mean, obviously, we can also run things like Synapse SQL Server in there as well. The challenge then, of course, is that you're still loading the data into your cloud data warehouse from your data lake. So you're kind of loading the data from the data lake into a cloud data warehouse that's also in the data lake as well. So then we start thinking about next phase, which is this element called a data lakehouse. And what we want to, the aim of this really then, if you think about it, is to try and take advantage of some of the cloud infrastructure in a good way. So we've got this ability to store data in non-proprietary formats, Parquet, CSV, JSON, and that's been around for a long time. But start to give some of the benefits of data warehousing on that non-proprietary file system. So start to run data manipulation operations, even run SQL queries on data that's in JSON or Parquet format as well. And so actually the data lakehouse is really the ability to start not only querying the data, but we see it as a little bit further than that. It's actually start running what we call DML, data manipulation language statements on there as well. So inserts, update, delete operations as well. Okay, and that's where we're looking at for us to fit. There are some other things to consider then. All right, so in the past, for instance, pretty simply, if you had a folder of Parquet files, Dremio could connect to that folder and expose it, and it would look and feel like a table, right? So you could run select star from folder name. And if more files got added into that folder, then Dremio would automatically pick those up. It's really neat. The implication being that the data sets were all additive. You were just adding new files into that folder. But this is a slightly different nuance, right? Because actually what we're talking about now is actually also the ability to sometimes update the data. And now in column stores, typically Parquet, and I've worked with other column store databases in the past as well, what they typically do is they don't affect the existing file, they create a new file with the changed data in. Okay. And one of the benefits of that actually is you can actually then do things like time travel, because you can go back to the earlier state as well. Think about it. Instead of using files 1, 2, 3, you now want to use files 2, 3, 4. But you've therefore got to wrap around within that folder. You can't just select from everything in the folder now. You've got to be a bit more clever. You've got to work out which are the files that constitute the latest set of my data. And that's when we start then talking about table formats. Okay, so table formats allow us to wrap around our Parquet folder a metadata description of what's the current state of this. Okay, so now let's have a discussion about open table formats. Iceberg predominantly, and Delta Lake as well. Okay, so I must admit we've got a slight vested interest in one of them because we were a very early contributor to the Iceberg project. And we've even written books on it as well, so if you want to have a look at the O'Reilly book on our features about Apache Iceberg, you can. But we're a very pragmatic company, okay? We work with open standards. And actually, Dremio, when we first started supporting any of these formats, we actually firstly supported Delta Lake. We can run selects against Delta Lake formats through Dremio. And the reason for that was early adoption was through Delta Lake. We're very pragmatic in that way. We go where the money was. But we know that in the long run, we foresee that there's more adoption for Iceberg, and there's actually more contributions to Iceberg as well. And so that's where we see that the industry is predominantly heading towards in the long run. Don't take our word for it. This is from GitHub, contributors to both of them. You see that in the Delta Lake side, this is not really a criticism. This is, Dremio itself is an open source project, right? And the primary contributor to Dremio is Dremio. So basically Delta Lake is owned by, is a Databricks project, so they're the primary contributor to there. But there are some others. Microsoft have done some bits, Uber as well. But if you see over on the left-hand side there, there's a lot more contribution from a lot more wider source of sparse of vendors on the Iceberg side. And so everybody's contributing towards a common goal there. Everybody's contributing things which help everybody else as well. So there's a lot more features, a lot more capabilities being added in by different developers. We're still involved in this. We still contribute to the Iceberg project as well. And adoption. I mean, this is probably a bit unfair. I mean, we do know Databricks is but we also think about here about the manipulations of data. I mean, Dremio can select from Databricks data sets or from Delta Lake. But actually, even things like Snowflake are moving into that now. So Snowflake have now got a connector to go down to manipulate Iceberg data as well, which is quite a major move. If you think about it, Snowflake were very hot on the proprietary element, but now they're seeing the movement towards Iceberg as well. So we're seeing Cloudera and some other tools as well also being in there too. And AWS is in there as well. Okay, so this is the sales slide. This is why we're kind of saying if you're going to choose a query engine, therefore choose Dremio. It's a SQL Lakehouse platform. Basically, we're not looking here to load the data into Dremio. We run queries on data that's in situ back on your data lake. So the data could be in Parquet, Iceberg, CSV, JSON format, but we'll present that data through a layer that makes it looks and feels like a database. Okay, we've got lots of companies. Okay, yeah, everybody has one of these. I did have a slide with more on, but I thought this will do. We can come to our booth and you see there's more. Is Microsoft mentioned on here? We actually have Microsoft as a customer, which is interesting. They've chosen us in some areas rather than Synapse, which is just worth mentioning as well. But we also have a lot of enterprise adoption. We're still a fairly young company. We've got this narwhal feature here, which is kind of a unicorn type little toy, if you want to have a play with that as well. But we also do contribute to other pieces as well as Iceberg. One of our major areas is Apache Arrow, which is the method. I'll talk about the performance features in a moment as well. But we also host a lot of conferences, one of which we hosted recently was called Subsurface. We had a lot of different speakers there. Look, customers, we even got customers talking as well, positively about us. That's just always a good thing. So how is Dremio different? I know there's a lot on this slide. I'm not going to go through it all. I'd say look at the second and the third columns really first. I love the second column here because it's fast enough for BI. We're not saying we're real time. You know, we're not as fast as a in-memory SAP HANA database. We'll never be. We've got to get the data from your data lake up into our executor nodes very quickly. The way that we do that, by the way, is on that second slide there, is using these concepts called Apache Arrow, which is a method of getting the data from S3 or ADLS bucket in on Parquet format very efficiently. And also on that third column there, we talk about a multi-engine architecture. Dremio runs across a series of what we call executor nodes. So you can have a cluster of 30 nodes. So when you run a query, it will automatically spawn that job to 30 nodes, and they'll be fetching the data in parallel from your data lake as well. Okay. There are some other pieces. We've got some caching capabilities. We've got also some other features on the third column there to do with isolation of workloads. So if you've got a noisy neighbor, that classic one with a data scientist, they're running those killer queries, and you don't want to affect your BI users, you can segregate those out into effectively what we call engines, but they're really subsets of nodes within the cluster. So we've got some nice workload management tools which will segregate that workloads across as well. Okay. The first column on there, semantic layer, is really quite a nice feature for data engineers, but also even for end users to work with. Essentially, what we can start to constitute and build up are these layers of what we call virtual data sets, but are very analogous to something like a view within a relational world. So you could have a virtual data set that maps to maybe a single source, S3, but could also combine data from, I don't know, S3 and SQL Server into a virtual data set that end users can consume. So you can have a virtual data set that's based on a virtual data set. There's no physical movement of data. So even if users are accessing via this VDS layer, they're still really getting the data from in situ. Okay, they're getting the data from the data lake or from their relational sources as well. And finally, we've got some security bits in there as well. We can do fine-grained access control, integrate with Active Directory and all that stuff as well. So we're proper enterprise-wide from companies you'd expect. And finally, on the right-hand side there, we're talking about more of the open data architecture stuff. Yes, so the fact that we support Iceberg, Delta Lake, DML, data manipulation language statements as well. We're also looking, I'll talk a little bit towards the end if we've got time, is talk a little bit about Arctic as well, which is kind of the next phase of this, to talk about multi-statement transactions and some of the housekeeping bits as well. Okay, so what we'd think about the typical components. We'd say Iceberg rather than Delta Lake because we think it's more open. It's a very performant table format. It gives us data consistency, so users can be manipulating data, other users can be selecting, and they're not going to see it they're going to see it in an atomic form, either before or after the change. Spark, we're very pragmatic here. We know people are already using Spark against Iceberg, so that's what I'm going to show you first, is how to start from Spark and then start to incorporate Dremio into this. But it's used in open source distributed packaging, you know, typically for data streaming and machine learning workloads. Then we're looking at Dremio. Dremio Sonar is kind of our engine, which is used for really analytical workloads. It's a SQL-based access, so Dremio will, for end users consuming and connecting via other tools, so imagine it's a SQL tool, you can connect Tableau, Power BI, the Jupyter notebooks of your choice, anything via ODBC, JDBC, it will look and feel like a database at that point. But it can connect to multiple sources, so we can connect to multiple S3, ADLS, Google Cloud, SQL Server and so on. But we can present those data sets as virtual data sets, okay? So we don't physically load the data into Dremio. And also we can then integrate with lots of client tools because we're ODBC, JDBC compliant as well. So how do we think this will fit together? Okay, so very basic diagram. Our art isn't great, but there you get the gist of this. The one in the cloud there is a cloud, okay? We've got some Iceberg data sets in the middle there. We don't know what the storage is. It doesn't really matter. It could be Hadoop, it could be S3 or whatever. And we've got maybe Spark, which is creating those Iceberg tables right now, okay? The way we've envisaged this will fit in is use Dremio, can also manipulate that same data. But actually, Dremio could also then connect to other things, and it can be connected to by other client tools. So you can use REST API, ODBC, JDBC to connect your Power BI, Jupyter Notebooks, and so on. And they'll be using SQL, like they would a database, to connect to that data that's exposed in Dremio. But actually take that further. You know, we're pragmatic, and we realize that not all your data's in a data lake. It might be more than one data lake for a start. But let's say it's in other data sets within your existing cloud. Or we can connect to Snowflake and expose that data as well. So you can have a data set that comprises of Iceberg and Snowflake data, for instance. But other data sets, we have customers who say, well, we've got some on-prem, old relational data sets. Can you augment data from there as well? We can do that as well. And notice the dotted lines here. Those are intentional. What we're really saying here is we're not physically loading the data into Dremio at any point. So if the data changes on the source, Dremio will see that because basically we're running queries against those sources as well. Okay. A bit of code. I know this will get people excited on a morning, Friday morning. We'll also see a bit of code. This is kind of how to create, use Spark with Iceberg. You install Spark. I'll show you a demo of this in a moment as well. But basically, it can be a bit cumbersome, eventually, Spark. People it's very codey. Okay, so to start creating data sets in Spark, it's fairly simple in there. But people maybe are more used to using SQL to do these things instead. So I'll show you the same using Dremio. Okay, it's the same, really the same operation. In fact, I've given you two options here. First one is to create a table that's empty. You can issue a create table statement, lo and behold. Okay, so that'll create a data set that's on your S3 bucket without any data in at this point. But we can also load data in, so we can run an insert statement. Hopefully, for people from a SQL background, there's nothing surprising on this slide. It looks and feels like a database, which is a good thing, because that's what you want, because you're already used to doing that. So you can create table as a select statement, so if you've got to select from another source. We've actually also just introduced a copy command as well, so if you've got data that's just in a JSON form or in a folder somewhere else, you can load that directly in as well. But also then you can run insert statements. So again, if you're used to running SQL insert statements against your data sets, you can do that here. You can insert a single row. You can insert from a select statement, so insert the results of a select from somewhere else. So in this case, now we've got a table with 3 rows in, 1, 2, 3. We can also join that, but actually I'll come on to that later on. What we can also maybe do is merge. You know, there's operations where you've got the data in a staging data set, and you want to now merge that into your new Iceberg table. We support that as well. So we've got a table here, which is our existing one on the top left, which has got those 3 rows in. And on the right, we've got some new data that we want to merge. Look at row 2 there. That actually already exists on the left-hand side as well. So really what we want to do then is update that record, but row 4, record 4, we want to insert that into our data set. And we can do that in one operation. Okay, it's the merge statement. So there's nothing proprietary in this. This is a standard SQL command. But you can now merge into Iceberg data sets. And bear in mind that source data set there could be anything. You're looking at Dremio, it could be merging from a completely different source. It could be a JSON object somewhere who've exposed as a looks and feels like a table. So think laterally here. That source there doesn't have to be even in the same place as the original as well. What we then see, by the way, for you interested in what the result would look like, lo and behold, 2 has been updated and 4 has been inserted. Okay. Okay, I'm going to do a demo. Well, what time are we on now? How am I doing? 10 to 2. Great, okay. I'll use Spark to create an Iceberg table, and then I'll add some simple rows in. Okay, we're not going to do massive volumes of data today. It doesn't really make any difference to the demo. It just means we'd have to wait longer for those pieces to occur. Then I'll use Dremio to expose that same data set. So we're going to look at that data set we've exposed in Spark. And then I'll use Dremio to manipulate that same data, so I'll add some more data in. We'll use some of the other features that are available in Iceberg, so you can look at the snapshot to see what the changes have been made as well. I'm then going to use Dremio to show you how to do a join. Now, I'll try and keep the coding fairly simple on this, because sometimes I'll adopt the persona of maybe an end user who doesn't know how to write the join themselves, but show you how using the Dremio UI, you can join to data sets without having to do too much of that as well. And then I'll show you the merge statement as well. Then we'll expose that data via other tools. So we'll look at Tableau, Maybe I might use DB Visualizer or DB Viewer as well, depending on how much time we've got. Okay, so yeah, demo, let's see. Okay, so I'm starting off here with a Jupyter Lab, which is going to connect through to a notebook. So the first bit here, I'm just going to, this may take a while. I'm going to install PySpark, and we're going to run through. So whilst this is running through here, there may be a delay whilst PySpark starts up and installs. So that's when we can use, you may be wondering why there's a narwhal over on the left-hand side here. That's so they can do a dance during these particular operations. You don't have to do anything yet, narwhal, but just wait and see. So let me run through these first parts. So basically, we're going to use a Hadoop catalog basically to do this operation. It's going to import a PySpark. This gives you some idea of how long the things are going to take to run. Okay, okay, let's see. The third section here, all I'm really doing on this third section is just basically defining a table name. So I'll wait for this one to complete first. Do you want to do a little dance at this point, Narwhal, just to keep people entertained? Okay, thank you. Okay, okay. I love it. I don't get any rounds of applause for anything. Oh, he's just a man in a suit, right? Okay, let me define my table name. Thank you, Noble, you've done your job. And then I'm going to create the table. So it's going to be called SQL B00. You see the name there, 203, so it's got today's date on it as well. So what it's going to do is, this might be things that people are already familiar with. So the reason I'm showing you this for now is this might be the world that people are already in if they're using Spark and Iceberg. So this is kind of just laying the foundation to stuff you might or might not already know. Has it created that table? It's still, can I have you again, Noel, just to distract from this slide for a moment? Thank you. Kiss a round of applause again. Okay. Okay, I'm not really happy about that. But anyway, so yeah, we're going to create a table. Has it finished yet? I haven't created a table. Come on. Come on. Okay, we've created a table. Finally, I'm just going to insert some records. So it's only, I'm just going to insert 2 records into here. And then I'll read the table, and we'll see what the data is at that point in time. Okay, in fact, whilst that's running through, okay, it's done one stage there. Another quick dance, please, Noel. Please don't do a clap. I love the awkward silence much more. That's better. We could all leave the room, right? Okay, right, so I think, has it done yet? It's still inserting the rows. Whilst that's actually starting up, what I'll do is I'll show you my Dremio UI. So that'll load, actually, just for your little face, just a sheet. There we have, we've got 2 rows in there now. Product ID 1 and 2, okay? Now, I'm just going to log in. I'm going to log into, this is Dremio UI. I'm going to log in via username and password for now. We connect to SSO and things like that as well. But if I log in from here, and I've actually already got a connection through to that same S3 bucket where that data set has been created. So if I just scroll down, I'll talk more about these areas at the top left here. These are called spaces. Essentially, that's where we, as an end user, you would consume the data sets from. Okay, so that's where we'd store the virtual data set definitions. And so we can now apply our back controls on any of these spaces to say, maybe this group can access this set of spaces and other people can access others. But as an administrator for now, I can also access the raw sources down at the bottom here as well. So you see I've got a source called S3, which is, it is an S3 bucket actually. And I've got a folder called Iceberg, and if I go to default here, we should see down here, SQL, there we are, this is one. You see the little one here. This is the one that's just been created via my demo by Apache Spark as well. So I could actually then decide here just to format that whole folder at this point. And Dremio recognizes it's an Iceberg data set. And by clicking save there, I'm not loading the data into Dremio, right? All I'm doing is creating a connection through to that Iceberg data set at that point. So, and I can run a preview on that, and we should be able to see then, we can see that, those same 2 rows. So it's very easy to expose your Iceberg data sets in Dremio. Okay, in fact, to be honest, I could have just run a select star from, and Dremio would have automatically found it, discovered it, done that metadata discovery in that initial query as well. So I didn't really even have to use the UI there. I just wanted to step you through. Okay, like a best cookery program, I've got some tabs already open here where I'm going to do some of the manipulations on. Okay, so let me start off here by, I'm going to run an insert statement using Dremio. So it's the same data set, and then I'm going to follow that with a select statement underneath. Hopefully that'll run through. So I'm inserting using a SQL, standard SQL command just to insert a record. It's added that record in. It's a lot faster, so no dancing either. Static normal there as well. So they've got our third record being added in as well now. So just making that point that here, it's the same data, right? So I could go back into Spark, into my Jupyter notebook now and see this same data as well. So I could be manipulating via various tools. But I also can do other things now. So I can actually look through. This is an Iceberg feature which is to do with table history. So we can actually look to see what the changes have been made against this data set. So if I run this query through now, we'll see actually there's a couple of records in here now. The first record here is when we've created the table, what was that, 1031. Remember, I inserted those initial 2 records at that point. And look at this one. This is what I've just done here, the second record down there. And so I could actually run an at statement at a certain point in time, select star from, and it will give me the data at that point in time as well. So that's a kind of I'd almost say a side benefit of Iceberg. You're able to do time travel as well in there. I've written a blog on that if you want to have a look. Okay, it's a very nice blog. It helps you through the whole thing. Also, we can do merge operations. So, for instance, I might decide to merge into my new data set, into SQLB. I've got this data set here which has got some other data in. So I could just run a merge operation to merge new rows in as well. So I can actually run this merge and then run the select statement afterwards. And I'll have a whole new set of rows in there as well then. So you can start to do various operations in here. Oh, why's my select failed? I bet I've not got I forgot to change my table name there. Okay. Let me just run this one through. There we have it. Okay, so, and I could be using other tools for this, right? So, although I'm using Dremio's UI SQL interface, I could be using other tools. There's nothing to stop me here, for instance. So this is the same data. If I run a preview in here, now we see the same information coming through. But actually, I could start to run through and say, use, I don't know, DB Visualizer or something. So I could just take this path here. Now, because I'm an administrator, I can access this raw data set. I might decide instead to access it via a virtual data set instead. But let me just expose this for now. I just run a SQL. So I've got a connection here. This is just a JDBC connection. And if I just run select star from and the name of that data set now, I'll just put a limit on so I don't need to get everything back for now. Actually, I could run a query directly against that cluster. I'm connecting from SQL, a JDBC tool through to Dremio that's then going fetching the data from my Iceberg data set as well. So by that, I hope you realize that you can hook in anything. Okay, you can hook in any tool of your choice at this point in time. So I could, for instance, as well, if I wanted to now, decide to expose via Tableau. I could run a report against this. So if I just click on Tableau for now, what Tableau will do, I mean, I couldn't launch Tableau desktop anyway, but I've just got the icon. And we normally have a Power BI icon on here as well, so I'll use Tableau for now. It doesn't make a massive difference to the demo. But the point being, I mentioned earlier on that we often use direct query, and this is what we're going to do here as well. The most tense part of the demo here. Can you do a dance here, Gnarly, whilst I just try and remember my username and password? I could have set this up to do single sign-on. It also stops me. Please, honestly. The point being, back to me, please. When I'm launching Tableau here, it's launching in context of that data set. Yeah, so notice here I've got all these columns in here which are in that virtual data set, so I could start building a report up directly. But I haven't loaded the data into Tableau here. So I'm running a direct query from Tableau to Dremio, and Dremio's going down to the data source to pull back the data. So if I pull back the category there as well, you see that we've got quite a lot of different categories in there as well. So, and that's a query that's been run. So it's very performant in that way as well. So if you're thinking about some alternative tool to having to build up, load data into your Power BI, data extracts and so on, this is a really good alternative to that too. They're very performant in that way. Take this a stage further. Maybe I want to, this is kind of to do with products, right? So we've got product ID, got a description and category in there. Maybe what I'd also want to do is maybe join this data to some store sales. So actually what I want to do is I've got existing store sales data, which has got a product ID in there, but I haven't got the categories in the store sales data set. So what I want to do is I want to join this data. Now I could write it via a SQL statement, but if I was a less proficient user, I can use it as a join condition. So I've got a data set available within Dremio already. It's not that one. Let me do a custom join instead. I'm going to join through just to a data set that's down here under my demo 01. I've got one here called, there we have it, store sales. So I could apply that and say, this is the join I want to do. So I can join on the product ID. I'm going to join that to the item SK here. Okay. Actually, I'm going to do a little bit more complex. I'm going to do a right join because there's some store sales information that doesn't have a product ID. So I'm just going to apply that as a right join and apply that change. Okay. And that will then show me a wider data set now. So if you look now, we've seen all this store sales information over the right-hand side. And for those that have got a category, a description, so on, it's showing me over on these left rows. So the reason it's showing some null values in there obviously is because we don't have a match for this item SK as well. Now, if I wanted to expose that to an end user, I would probably don't want them running that query, this big query underneath here to do the join. So this is where we can start to create these things called a semantic layer. Essentially, what I can do is I can save this view of the data, and I'm going to store this within one of those spaces that I had earlier. So if you notice, I've got a space called, let's go into demo 02, and let's call this Mike 01. I'm very unadventurous with my virtual data sets names. It doesn't really matter what I call it. And so now an end user could consume that data set themselves. And actually, they can do a variety of things from here. You know, they could actually connect via running a query directly against demo 02. So I might have a user who doesn't have access to the raw data, but could access the data through that particular space. So for instance, now if I go back into, I don't know, DB Visualizer, you probably see down here, I've got one already very similar. What do I call it? Mike 01. And if I run this query through now, you'll see that actually what I'm now doing is I'm connecting through to that virtual data set, which is comprising data from two sources, you know, without the user having to write the query themselves. So they can now start to ingest this data in a really easy to consume way. And they could build those data sets themselves. They could even use that demo, that Mike 01 data set as their starting point to do further curation themselves as well. But keep in mind, although we're not duplicating the data here, we're not doing anything to do with, so I'm actually physically running against the sources. One other thing that's worth bearing in mind there, I've just created a virtual data set. We don't know really much about the governance and the lineage of that now. So just to point out here that Dremio's got some other nice features in here. For a start, we can introduce a catalog. So we can actually just start to describe what the data is. So if we wanted to, we could make this really easy for other people to start to consume from this point. We can even add tags. So for instance, I don't know if Gemma here wanted to start working with this data set, but can't make it easier for her to discover, I could just add a tag for Gemma. And basically, she would then be able to log in the search bar on the top left here, type in Gemma, and she'd find this data set really easy as well. So it makes collaboration very straightforward. One other thing is, this is a virtual data set, and the reason I know that is because we've got this little green icon here, rather than a purple. Okay, it just means it's a virtual rather than a physical data set. But what's it based on? So Dremio maintains the lineage as well, so we show you from the graph. Bear in mind this data set I've just created now. You see me create this data set, right, called Mike 01. But where is it based on? Well, it's based on two other sources. It's got two parents. One is that Iceberg data set that we've just created during the demo, and the other one is this store sales data set that was created before the demo. But actually, we can go all the way back to the sources themselves here. They happen to be both S3 layers, but it doesn't matter. One could have been S3, one could have been Oracle or something else as well. Okay. I've done everything I thought I would do in the demo. Thank you. I'm going to talk through a few more bits. We've got about a few minutes left about what we envisage will be the next phases of the Data Lakehouse. And then hopefully we've got time for questions as well. From Data Lakehouse, I've shown you most of this slide already earlier, the timeline. But actually we've added an extra bit on the right there as well. It's to do with the fancy name 2.0. But if you imagine what we're considering now is this ability to manipulate data, maybe in Parquet form. And so we start to end up with a lot of files which are left historically behind the scenes. Yeah? So how do we tidy those up? We've also got to consider other types of manipulation that might be required within the data warehouse, such as the ability to do multi-statement transactions. It's not just manipulating one data set, manipulating multiple data sets, and make those changes available as an atomic unit. Okay, and this is what we're looking at next. There are some other areas as well, as I mentioned, things like housekeeping as well, how to tidy up those old files. And so this is what we're looking at now. We started off here by thinking about, open file formats, typically Parquet. It could be Orc as well, that's sometimes around, but Parquet seems to be the one that's winning. Then we started looking at open table formats. So we started to look at Iceberg and Delta Lake. But actually now we're also looking at this other third element called, which we've kind of given them as data as code. And that's one way of looking at it. I've been talking to various people in the last couple of days about what they think data as code is. Other people think of it as a multi-statement transaction. Let me give you both of, it's the same outcome, but it might be different, resonate with different people in the room. Data as code essentially allows us to start taking a branch of a data set or multiple data sets and start working within that branch and do manipulations of that data without anybody else being able to see those changes until you're happy with it. Okay? And then once you're happy with it, you can then merge that branch back into the made code line. Everybody then sees those changes as one atomic unit. They see either in the state A, before the changes were made, or state B, after. Okay. From people from a database background, what that really means is you've got the ability to run multi-statement transactions. You can run insert, update, delete operations on multiple data sets, but when you normally would run a commit statement, essentially now we're running a merge operation instead, and allow that operation then to be put back into the main point. So that's what Arctic is really doing. So that's one of our other projects. So we're looking now at Dremio Arctic as being kind of a data lake management service. Yeah, so it's now allowing us to do the management of data that you'd normally expect a database management system to be able to do, but on data lake, on non-proprietary data formats as well. Okay. So it does serve also as a meta store. So Arctic actually can work as a meta store, so you don't need to use Glue or the Hadoop meta store anymore. We're also introducing optimization. Now, I spoke to someone yesterday, they really didn't like this idea. And I said, wait, what we mean by optimization here is more of the housekeeping stuff, the hoovering, the vacuuming, not hoover, vacuuming of old files that you don't need anymore, which is just historically there because they were inserts that occurred in the past as well. Okay. And finally, what we're also looking at then is this element called data as code. That might resonate with you. Think of it another way as multi-statement transactions as well. Okay, so that's where we're aiming for. And Arctic is already available within Dremio Cloud, and it will be available on the Dremio Software Initiative soon as well. Just be aware about the naming terminology, okay? Dremio Cloud is a managed service, okay? But actually Dremio Software can also run in the cloud, it's just you manage it yourself. So we can install on multiple cloud environments, we can install on-prem. I've had people coming around saying, well, can I put it on my laptop? Yeah, I've got it running on a VM on my laptop if you really wanted to. You can run Dremio in that way as well. It won't be as performant as a multi-node architecture, but you can get started with us really easily. If you want to find out, and this is the key word on this slide, I think, is those last two words on the title there. That tends to get people very interested. There is a Dremio Community Edition version, so you can download that for free. There's no time limit on it. There's no node limit on it. The only limitation on the CE versions is we don't have the security features in. Okay, you can log in via username and password, but everybody's an administrator, so everybody sees all the spaces. Okay, if you want to start incorporating Active Directory and so on, that's when you need the enterprise version. But you know, we have a lot of users who get up and running using the CE version. If you're really interested, I've done this a couple of times. It was a really wet Wednesday afternoon. I had no else to do. You can build it from the ground up, so you can actually build it from the source code if you really want to. Most people don't. They just use the pre-built CE version. But if you really want to get your hands dirty, you can do that. The one that we're also pushing very heavily in our session at our booth is to test drive in the cloud. What you've basically got then is the ability to run a pre-installed Dremio instance in the cloud, but we're paying for the cloud infrastructure for that. Okay, so if you want to run a test drive, just click on this place here or come to our booth and we'll show you how to do it. And you get an email back inviting you to connect to your own cloud environment. From there, what you can do is, when you install Dremio, you're typically allowed to, there's some sample data sources you have available straight away with different data formats, Iceberg, JSON, Parquet, and so on. But you can still connect to your own ones if you wish as well. But that might be enough to get people up and running. Obviously, if you want to come and buy the product, we've got various salespeople here who would love to do that. I don't think that's likely today, but you never know. I thought I'd have to say that as well. And that's it, okay? I think I'll stop there. I've got my email up. I don't know why I've put my email up. I'm asking for trouble for that one. But yeah, if you want to contact us anyway, feel free. If you want a narwhal, please come to our booth. I'm not going to throw them out for now and as well. But does anybody have any questions? Yeah, sure.
Yeah, I had one quick question. Thank you for that, by the way. In terms
Yeah, sure. It can be both of those. Yeah, so data analysts can be using it because we've got classic data analytical tools. I mean, we can do windowing and things like that as well. For the BI tools you've seen already, I mean, I showed Tableau there. It could have been anything. It just happens we've got a Tableau icon on the user interface, so I launched Tableau from there. But you can actually launch Power BI from the UI as well. But we have people using Looker, and even sometimes the thing is we're working with some customers so they've written their own BI or their own analytical tool. As long as it connect via JDBC, ODBC typically, then you can connect to Dremio.
So the data engineering part where typically you write your transformations and source control, it probably doesn't fall into that space? Or?
Yes, so there could be, we would say we wouldn't put ourselves forward as a hard ETL tool. We'd say last mile ETL. You can do kind of the transformations we're doing are normally things like virtual transformations, you know, changing a column name or changing a data type or merging data sets together. But you've also got some security elements in there as well, because we might decide you've got a raw data set that you don't want to expose this particular column of. Well, in this case, no one has access to the raw data apart from your admin, Dremio admin, but you create a virtual data set that just excludes that column. Or masking as well. We have a lot of users who, maybe you've got a common data set where everyone wants to connect to, but based on your own credentials, whether you'll see a masked version of that data or not, we can define that at individual column level as well. So yeah, and the thing is then that all the data sets downstream that then you might create would inherit that security as well. You know, so if you create a virtual data set based on a data set on which you only see masked data, then the child data set will be masked as well. Yeah. Are there any questions on the, no responses on the line? Okay.
I'll ask one more quick one related to that, sorry.
Sorry?
In terms of those virtual data sets then, from BI analysts, are they version controlled back somewhere, or is this inbuilt version controlling?
There is inbuilt version control insofar as, maybe I could show you in the UI again, because I made a simple change in here. If I go back to the one that I created, you notice over on the left-hand side, you've got these breadcrumbs that actually show you the changes I made to that data set as it was built. So I can step through it within Dremio, certainly. Probably your question is more related to, could you do all this as code, right? Everything I've shown you today, you can use from the command line. That's typically what people want to do. So maybe you've got a GitHub repository or something where you want to store all your virtual data set definitions. Absolutely. So everything I've shown you today, I've just used the UI just for reasons of speed. But you could create the data sets, the spaces, the permissions. Everything can be done from a command line as well. Yeah. And bear in mind, rebuilding the Dremio environment doesn't necessarily take that long because we're not loading the data into Dremio. You know, so we have some organizations where they actually have multiple Dremio instances, sometimes pointing to shared sources because you're not loading the data in as well. For reasons of, we had one recent for a company which had Finland and Sweden, and they had some Swedish data that the Swedes didn't want to share, couldn't leave the country. So we had a local instance in their environment, but the shared data, we had an instance in Finland which could see the shared Finnish data and the shared Swedish data as well. Yeah, so there's a lot of options you have. Yeah, sure.
You're talking about it as a kind of semantic serving layer, and you build a new layer over your lake. What do you have the options around row-level security?
Okay. So the question is about row-level security. Absolutely. So I mentioned masking earlier. Yeah, so actually that's a column level kind of thing. But if you imagine when you create your virtual data set for the masking element, essentially within the select clause, pretty simply for now, but within the select clause, you could have almost a case statement. If the user is Mike, then showing the data. If it's you, I'm going to show you the master version. That's really kind of simplifying how the, but for row level security, you simply have something in the where clause that would say, okay, Mike can see UK data, Zach can see everybody. You know, that's kind of how it would be implemented. I mean, I've very simplified it there, but you understand the principle, yeah. Yeah. And the idea then is that multiple users have access to the same data set, but the results that they see are different depending on who they're logging in as. Or it could be user or group level. And those users and groups, remember, don't have to be, they could be AAD users groups we can be using. Okay. Does anybody want to see a final dance from the Ollie? Okay, Ollie, take it away. Thank you. Great. Thank you, mate.